The shipping industry worldwide depends on heavy fuel oil for operation, which discharges a huge amount of sulfur oxide, nitrogen oxide, particulate matters, and carbon dioxide. The International Maritime Organization of the United Nations has enforced regulations on these pollutants. Liquefied natural gas-fueled shipping complies with the UN regulations and is cheaper than heavy fuel oil. International regulations on sulfur oxide, nitrogen oxide, and particulate matters are implemented in the emission control area. The current ECA includes North America and Europe. The ECA will be expanded widely in the future. LNG has many advantages to fuel ocean-going ships. Carbon dioxide is reduced by 30%, nitrogen oxide by 80%, sulfur oxide and particulate matters are almost entirely removed. And the price of LNG is half that of heavy fuel oil. LNG is environmentally friendly and cost-effective. LATTICE Technology has been developing global LNG infrastructure technologies for LNG-fueled shipping. An LNG ship bunkering terminal is assembled and built in a dry dock. First, hull structures are assembled for LNG storage. Many systems are installed on the top side. At last, guide piles are attached to the hull. Now, the bunkering terminal is ready to move to the service port. Before the terminal arrives, the seabed base platform is fixed to the seabed. When the terminal reaches the port side, the guide piles are lowered and combined to the seabed base platform. The storage capacity of the terminal is 250,000 cubic meters. The hull is 276 meters long, 56 meters wide, and 28 meters high. The terminal can cover 12 million cubic meters or handle 6 million tons of cargo containers every year. It can serve 40 ships every day or 14,600 ships every year. The guide piles allow the bunkering terminal to move up and down with the sea level. However, they restrict the ship motion in the horizontal direction. This function guarantees a safe ship-to-ship LNG transfer even in rough sea conditions. An LNG carrier is approaching to the LNG bunkering terminal to supply a fresh load of LNG. The active docking arms speed up the mooring of two floating giants. The LNG is transferred from the LNG carriers to the terminal. The LNG bunkering terminal supplies 4 LNG bunkering shuttles at once. The bunkering shuttles leave for their client ships. The LNG fuel tank is the critical component for LNG fueled ships. POSCO and LATTICE Technology jointly developed a prismatic lattice pressure vessel that can store 15,000 cubic meters of fuel LNG at 7.5 bar. This amount of LNG corresponds to the fuel consumption of a large container carrier for 1 month. However, many of the containers should be removed to provide the space of the LNG fuel storage. The ideal volume efficiency of the lattice pressure vessel enables it to minimize the lost containers. For example, one lattice pressure vessel with volume of 15,000 cubic meters can save nearly 900 TEU compared to the conventional cylinder storage. This means $200 million benefit for the ship owners. The fuel tank is full of high-pressure boil-off gas, or BOG, after a voyage. So, the first step of LNG bunkering is to remove this BOG from the fuel tank. LATTICE Technology has developed the BOG spray recondenser that uses sprayed LNG to condense a huge surge of BOG from the tank in a short time. To promote the condensation rate, the circulated LNG is subcooled through the cold box and sprayed over the BOG. After the BOG is removed, the LNG is applied to the filled tank. LATTICE Technology introduced the pump-free LNG booster. Part of the LNG is vaporized to pressurize the first booster, and high-pressure fuel LNG is exported without pumps. For the meantime, the second booster is filled with fresh LNG. Soon, they switch their role to guarantee continuous export of the pressurized LNG. The pressurized LNG is vaporized and fed into the dual-fuel engine to propel the ship.